Tesla has long been the gold standard in battery innovation, dominating the game with unmatched capacity and efficiency. But now, a new contender has arrived, turning Tesla's much-anticipated Cybercell into yesterday's news. This revolutionary battery is more efficient, packs more power, boasts a larger capacity, and honestly, it redefines practical usability. So, who is the company behind this shift? Meet QuantumScape, the Silicon Valley trailblazer giving Tesla some serious competition. Founded in 2010 by Jagdeep Singh, Tim Holm, and Fritz Prinz, the company started as a small startup. That changed in 2012 when Volkswagen, one of the world's biggest car manufacturers, took notice and teamed up with them, providing substantial funding. The momentum continued when Bill Gates also backed them with an investment. QuantumScape hit the headlines in 2020 when they revealed they were working on a game-changing battery. The buzz was immediate and global, with investors lining up to pour more money into the venture. The technology in question is QuantumScape's cutting-edge solid-state batteries. Think of them as the next big leap in EV power. For years, they have been hailed as the future of electric vehicles for good reason. While they are lithium-based like traditional lithium-ion batteries, they have a groundbreaking twist. Instead of using liquid or gel electrolytes, solid-state batteries rely on solid electrolytes, often made of polymers or ceramics. This seemingly small change is a game-changer, delivering massive improvements. First, due to a much higher energy density, solid-state batteries have a significantly larger capacity. This allows for a much greater range while being lighter and more compact. A lower curb weight makes the car more drivable and efficient. Essentially, this could lead to range-efficient vehicles that are not overpowered, potentially resulting in a considerably lower price tag for future EVs. Furthermore, despite being lighter, solid-state batteries allow for a higher power output, enabling the creation of faster electric vehicles. Another major advantage is their higher voltage tolerance, which translates to much faster charging times compared to regular lithium-ion batteries. Perhaps the most significant reason they are considered better is their enhanced stability. A primary concern with regular batteries is their combustibility. Standard lithium-ion battery cells combine a flammable electrolyte with a significant amount of stored energy. Once a battery cell generates more heat than it can disperse, it becomes susceptible to spontaneous combustion in a process known as thermal runaway. This can be caused by short-circuiting, mechanical damage, overcharging, or overdischarging. In contrast, solid-state batteries are considerably more stable. They are less prone to ejecting flammable or toxic gases because they are completely solid and lack any easily flammable liquid. It is incredibly interesting to note that solid-state batteries existed as a concept for almost 2 centuries. Michael Faraday was the first person to discover solid electrolytes back in the early 1830s, which formed the basis of all future development in solid-state ionics. However, these batteries were historically known for their short lifespan due to the rapid depletion of their solid electrolytes. Despite this flaw, the concept remained a viable idea for the future. QuantumScape's strides in pioneering solid-state battery technology appear to have Tesla in a tight spot. It may only be a matter of time before other manufacturers adopt similar technology. This raises a big question. Can Tesla catch up? To start, Tesla is a giant in the industry, a well-oiled machine with immense production capabilities that extend far beyond research and development. Unlike QuantumScape, which focuses solely on battery R&D, Tesla has a proven track record of delivering groundbreaking products that have reshaped the EV landscape. Tesla also has the resources and strategy to outmaneuver competition, including acquiring startups to fast-track their development. If QuantumScape proves its worth, nothing would stop Tesla from making an acquisition. However, there is a significant catch. QuantumScape's work remains shrouded in mystery. Despite the hype, they have yet to publicly demonstrate tangible results to back their claims. This secrecy has led to skepticism. In 2020, the hedge fund Scorpion Capital accused QuantumScape of being a scheme after the startup secured over $1 billion in funding without delivering concrete proof of its technology. The lack of a viable product has fueled doubts about their legitimacy. This technological race is far from a zero-sum game. The advancement of solid-state technology by QuantumScape and others does not signal an end for Tesla. Rather, it illuminates a path forward for the entire industry. Tesla is not sitting idle. For years, the company has been conducting its own extensive research into next-generation battery chemistry through its Advanced Battery Research Group. Tesla's strategy has always been one of vertical integration and relentless iteration. While QuantumScape focuses on a revolutionary solid-state battery, Tesla is innovating on multiple fronts simultaneously. Their focus has been on perfecting the manufacturing process and driving down the cost of their current 4680 battery cells, which already incorporate significant innovations like dry electrode technology and a structural pack. This approach delivers immediate tangible improvements for their current vehicles. Furthermore, Tesla's immense advantage lies in its scale and proven ability to manufacture batteries at a volume and speed that is currently unmatched. Even if QuantumScape's planned production facility comes online in 2025, it would take years to scale up to Tesla's current output levels. This head start in mass production is a critical advantage. The ultimate future of electric vehicles likely will not be defined by a single battery type winning out. Instead, we will probably see a diversified ecosystem. Solid-state batteries might first appear in premium models where their higher cost is justified by superior performance. Meanwhile, advanced and continually improving lithium-ion batteries like those Tesla produces will likely continue to power the mass market for years to come, becoming ever more affordable. In conclusion, QuantumScape's progress has thrown down the gauntlet, proving that solid-state technology is moving from the lab toward reality. This has energized the entire sector and accelerated development timelines. However, to declare that Tesla has been left behind is a profound misreading of the landscape. The true legacy of this challenge will not be the demise of a competitor, but the elevation of the entire industry. It has pushed every player, including Tesla, to accelerate their roadmaps. This fierce competition ensures that the electric vehicles of tomorrow will charge faster, travel farther, and become safer and more affordable, ultimately benefiting consumers and accelerating the global transition to sustainable energy. The race is on, and everyone stands to win. This period of intense competition is honestly a catalyst for unprecedented innovation. Tesla's response to the solid-state challenge has been multifaceted, really reflecting its strengths as a vertically integrated manufacturer. While the core chemistry of their current batteries might evolve gradually, Tesla is making significant strides in the surrounding architecture and manufacturing processes. Their focus on the 4680 cell format is a prime example. By designing the battery cell to be a structural component of the vehicle itself, the so-called structural pack, Tesla is achieving weight reductions and efficiency gains that partially offset the energy density advantage promised by solid-state technology. This pragmatic approach delivers incremental benefits to consumers today, while buying time for their own next-generation battery research to mature. Furthermore, Tesla's ambitious goal of producing 20 million vehicles annually by 2030 is not just a sales target, it's a battery strategy. This scale really necessitates relentless focus on cost reduction and manufacturing efficiency. Tesla's advancements in dry battery electrode technology, which removes toxic and expensive solvents from the production process, could be as transformative for cost and environmental impact as any chemistry change. Even if a competitor brings a superior battery to market, Tesla's ability to produce good enough batteries at a scale and cost that others simply can't match will remain a formidable advantage for the mass market. Looking beyond Tesla and QuantumScape, the entire automotive and chemical industries are investing heavily in solid-state technology. Traditional giants like Toyota, Ford, and Volkswagen, along with battery specialists like LG Chem and CATL, are all pursuing their own versions. This broad-based effort really suggests that solid-state technology is indeed the next logical step, but it also indicates that no single company will hold a monopoly. The future market will likely be fragmented, with different chemistries and form factors optimized for different vehicle segments and price points. Change may be just around the corner. QuantumScape recently announced it's gearing up for mass production, with a factory reportedly under construction and expected to be operational by 2025. If everything goes as planned, this could finally reveal whether QuantumScape's batteries are revolutionary. But let us not mistake QuantumScape's potential success for Tesla's failure. The EV industry is vast, and it's unlikely QuantumScape will have the solid-state battery market to itself. Tesla, along with other major players, will undoubtedly innovate, adapt, and push the boundaries. The real winners in this race are electric vehicle enthusiasts, who will reap the benefits of cutting-edge advancement.